We can take this factoring by dividing process a step further. So in this next problem, it says show that x minus 2 is a factor of the polynomial and then factor completely. So if it's asking us to show that it is, then they're kind of telling us that it is. So you should get a 0 for your remainder whenever you do your synthetic division. Then we will rebuild the polynomial as that factor times whatever the rest of the polynomial, our quotient, is, and we will continue factoring by whatever method we need to use for that particular problem. So let's go ahead and set up our problem. I am almost at the bottom of a page I see right here, and I'm going to squish this onto this page. So I'm going to start writing way over here on the left so that I have some room to do some more work on the right for my factoring after I do my division. So I'm going to write a 2 there because it's x minus 2, so remember it's opposite. And then I check my terms, 3, 2, 1, 0. I'm good, and I can just write the coefficients, 6, 8, negative 34, and negative 12. And I'm ready to do my polynomial division. Remember that you start by bringing down the 6. 2 times 6 is 12, plus 8 is 20. 20 times 2 is 40, plus negative 34 will give me 6. 6 times 2 is 12, plus a negative 12 will give me 0. Okay, there's our proof. We have determined that yes, in fact it is. And we kind of knew that going in because it just says to show that it is. Let's label everything this time. Remainder, and then remember after that is constant, x and x squared. We need that because we are going to rewrite our polynomial as this factor, x minus 2, and then the polynomial that's left, the quotient that we got. 6x squared plus 20x plus 6. So we got this line with dividing. And now we want to continue factoring. X minus 2 is good. That's a linear term, but I want to focus in on the second parentheses here. And the first thing I notice is that I have a GCF of 2 that I can pull out. So I'm going to pull that out to the front as my next step and rewrite what I have left. The x minus 2 stays, 3x squared plus 10x plus 3. So again, this is our GCF step. And now I want to look at 3x squared plus 10x plus 3. Well, unfortunately, we don't have a 1 here, so that means we can't do the whole factors of 3 that add to 10. That doesn't work anymore because this 3 is messing things up. So we are going to be forced into guess and check. So we are in quadratic form, but we are going to have to use guess and check. So you can write quad form, guess and check. And so let's remember how we do that. We'll go ahead and write everything that we know is staying. We know that the 2 is good and the x minus 2 is good. We want to factor the rest of it. With guess and check, the first thing we look at is our front term. 3 is a prime number, so I know that the only factors of 3 are 3 and 1. I can at least write the front by saying 3x and x. I also only see positive signs here, so I know that I don't have any negatives anywhere. And now I want to look at my last term, 3, and think of the factors of that. Well, it's the same thing, 3 and 1. So the guess and check part is that I don't know whether the 3 goes here and the 1 goes here, or vice versa. So I'm going to have to try until I get the right one. Remember, if there were negatives involved, you might also have to move the negative and positive signs. But for this one, we just have to deal with the numbers. So if I put a 3 here and a 1 here, remember that the way to check it is to take your inner terms. Okay, so that's 3 times x is 3x. And then take your outer terms. 3x times 1, well, that's another 3x. That adds to be 6x. I don't want 6x, I want 10x, so I guessed incorrectly. I'm going to erase these and try again. And if I move the 1 and the 3, that's my only other possibility in this case. Yes, I have a 1x and a 3 times 3 is 9x. 1 plus 9 is 10x. So that's the position for the 1 and the 3 that works. Let's take a look. We have a monomial, greatest common factor here. Everything else is linear. So when I ask myself if I'm done, the answer is yes.